So, a very good morning to everyone, those who are participating in this one-day seminar on the climatic change and the role of AI in mitigating the climatic change. Okay, so my particular session would be on discussing about what are the different machine learning algorithms we are having to solve some of the climatic change problem statements. Okay, so I hope the why the all the governments like US, UK, and India also giving more importance to climatic change. And most of the research proposals and most of the recent debate are going on the climatic change. Okay, so we have the technology called artificial intelligence. Okay, so how can we make use of this artificial intelligence technique to mitigate this type of climatic change? Okay, so it may be a flood, or it may be heat waves, or it may be a earthquake. Okay, so we are having different climatic change. Okay, but the climatic change nothing but it will get into disasters. Okay, so landscape flood, and we are having the heat waves. Okay, so we are having a different set of AI techniques to overcome this problem, or to predict the yearly signs of earthquake or flood, like that. Okay, so in this particular session I'm going to discuss about some basic thing. Okay, like how to predict the weather using the support vector machine algorithm and some other machine learning algorithms. And it will be like it will take half an hour of time. Okay, and then I will get into the NVIDIA platform to discuss about a disaster risk monitoring. Okay, so in that we are okay, so and I am getting into the NVIDIA platform to discuss about disaster risk monitoring. Okay, so if you have any doubts in between the session, I request everyone just post your questions in the chat box. Otherwise, you can unmute yourself and you can ask your query. Okay, so and also I require it to be like a interactive session. Okay, so instead of one-way communication, I need a two-way communication. Okay, so let me share my screen. Hope my screen is visible, right? Everyone can able to see my screen. So if you do so, please take something in the chat box. I will send. Yeah, thank you so much, Dinesh. Okay, so before getting into this topic, okay, so I will discuss about some of. I will just have a quick point with respect to what are the different applications we are having with respect to the climatic change to solve the climatic change. We can able to solve using the artificial intelligence technique. Okay, so one is I already said predicting the flood and predicting the earthquake, and also predicting the a temperature or weather, whatever it may be. Okay, so we can make the rest of weather forecasting. Okay, and then so you know that nowadays we are moving towards solar power. Okay, so if you want to get a maximum solar energy from the sun, so we need to shift the angle of the solar panels with respect to the sun. Okay, so we can also make use of this machine learning techniques to improve the efficiency of the solar power panels. Okay, like and also the distributing the power to the distant stakeholders. So these are some of the areas where we can make use of this machine learning algorithm with respect to the climatic change. Okay, and then how to predict the ocean waves. Okay, so some of the areas with acoustic imaging. Okay, so we are making use of these deep learning techniques to solve that problems. Okay, and then so we are having another application called calculating the solar radiation from the sky images. Okay, so instead of calculating the sun's energy, so with the help of the sky image, we can able to calculate the radiation over that particular area. Okay, so these are some of the areas where we are having where we can apply our AI techniques to solve that. Okay, So in this particular session, I'm going to discuss about one of the such application that predicting the weather. Okay, so this is my weather. Okay, with respect to data, I'm having I hope everyone know about the machine learning, right? Okay, so if all of you know about the machine learning, can you give the quick idea about what are the parameters we need to have in the machine learning algorithm to build a model? Anyone? What are the things it is required to build a machine learning model? So we are having around 75 number of audience. Okay, so at least some of them you can just type your answer in the chat box. Okay, so let me get a decision. Okay, so I don't want to waste my time. So Manikan, is nothing but what are the different parameters or different, what are the different things we need to require to build a machine learning model? Okay, so in order to build the machine learning model, so we need to have a input data. Okay, so input data is very important. Okay, so in that input data, so we can categorize the machine learning into two such different techniques. One is a supervised learning and another one is unsupervised learning. Okay, so if you have the data set with the label with the target value, okay, then we can define that as a we can make use of the supervised learning algorithm to solve that particular problem statement. Okay, so if we don't have the target variable in our data set, so we need to have a make use of some unsupervised learning algorithm to solve that problem statement. Okay, so this is a major difference between supervised and unsupervised. Okay, so here we are having a PRP, Tmax, Tmin. Okay, so there is a probability of getting a rain on a maximum temperature, minimum temperature, and whether it will rain or not. Okay, so what type of problem statement is that? Either it is a regression or classification. So after looking this data set, can anyone say how can we solve this problem? Either we can go for a regression or a classification problem. Which one is the better suit for this particular data set? Okay, so this is what it is. Okay, so we are having input features and this is our target. If you look our target variable, so you can see, so we are having a true or false. Okay, so then we can define this is a classification problem. Okay, we can classify from the given set of input whether it is a true or false. Okay, so this is the data set. So whenever we want to work with the machine learning algorithms, we need to have some set of Python libraries. Okay, so some of the Python libraries are pandas, numpy, matplotlib, seaborn, okay, and scikit-learn. Okay, so these are the five important or most number of used libraries with respect to the machine learning algorithm. Okay, so pandas, a library used to do a data formatting, and numpy is a library used to do the numerical computation, and matplotlib.pyplot as a plot will be used to provide all the visualization part. Okay, and we are having a input seaborn. Okay, so matplotlib and seaborn is both a library which is used for a visualization purpose. Okay, so let me run this code. Okay, so we are importing the pandas library. So now if it is successfully imported, we don't get any error, any output like down here. Otherwise, if none of them has been, or if any one of them has not been imported, then we will get a no module error. Okay, so in that case, we need to import the library, and then we have to start again. Okay, so this is the data. Okay, so I am calling that variable the df, and this is a command to read the CSV file. Okay, so we are having a data set with a different file formatting: .csv, .text, .excel, .pickle file, .json file. Okay, but for this particular problem statement with the ready-made data, what we are having is, so the data with .csv file. Okay, so df equal to pd.read underscore csv. So Kaggle slash input slash that is a data set file name. Okay, and then I'm going to run this particular cell. Okay, so once you run this particular cell, this entire data set that has been copied into your df, that is a df variable. Okay, so then I can go ahead to print the shape of the data frame and also print first 5 rows of the data frame. Okay, so for doing that, so we need to have so this is a command df your file name dot shape and df dot end. Okay, you can see, so we are having around 25,551 rows and number of columns is 5. Okay, you know the first is the date, and then we are having a probability of rain, maximum temperature, minimum temperature, and rain. Okay, so we are having a 5 columns with 25,551 rows. Okay, so this is the first 5 rows. Okay, because so if you give a tf.add, it will print the first 5 rows. If you want to print a last 5 rows from the data set, if you need to give a df.tail. So if you want to print a last 10, then we have to mention here 10. Okay, you can see, so we are having last 10 rows. If you doesn't mention anything inside this particular bracket, then it will print a default value of 5 things. If you want to print any 2, then you have to mention 2. Okay, so this is what how we can be able to display the shape of the data frame and also printing the few number of rows. So from this data set, you can see the rain is a target variable, right? Okay, so we have to count the values. Okay, so how many number of trues and how many number of false present in that particular data set. Okay, so for that, so you know this is a file name and this rain is your column name. Okay, so we need to give the single quotes dot value underscore code counts. Okay, so from the data set, we are having around 14,648 false and 10,900 true. Okay, so can anyone say whether this data set is having any null values? Null values is nothing but the row which doesn't have any values over there. Can anyone say? Okay, so let me check. So whether we are having any null value or not. Okay, so if you calculate this, we are having around 25,548. But the initial data set size will be like 25,551. So we are from the we can able to see that there is a 3 missing values. Otherwise, it is a null value. Okay, so for column in df, print column. So for all the columns, we are going to calculate is null sum dot sum. Okay, so it will calculate whether that particular column will having any null values, and we have to sum, and again we have to sum again, because let us take an example. If I am having the a, so I need to add a plus b, right? So that's why we are having dot sum dot sum. Okay, so if I run this code, you can see in the date we are having no null values, but if you take the p or cp, so we are having a 3. Okay, and also if this is not present, then definitely the probability the rain will also not present. Okay, so we are having a 3 null values. Okay, so when compared to the values of 25,551, the missing values of 3 doesn't make a matter. Okay, so what we are going to do is we are going to remove that, or we are going to drop that particular row. Okay, so this is a quite big lecture when compared to null value imputation. So if you are having a probability of null values is minimum, then you can go and remove that particular features or particular rows. If it is not so, we need to do some data imputation technique like mean, median, mode, like that. Okay, so I'm going to drop that particular cell. So df dot drop na in place equal to true. So whatever the drop values we are having inside the particular data set, it will be removed. Okay, so then I can check a shape to check whether it has been removed or not. You can see, so previously we are having a 25,551. Now after removing that three particular rows, it has been reduced to 25,548. Okay, so and then I'm going to if you take the data science pipeline, it will start from the data collection and then data pre-processing, model building, model training, model evaluation, and model deployment. Okay, so initially the step would be like we need to do a n number of or some different EDA analysis, that is exploratory data analysis, to get some useful insights from the data. Okay, so I'm going to use a U plot. Okay, so to find the distribution of target variable or distribution of relevance to, so how the target variable will have the effect on your PRCP maximum temperature and minimum temperature. Okay, so let me run this particular cell. Okay, so that orange dot, it would be, it's a true, that is it will be raining, it will be rain, and the blue dot will be false, it will not rain. Okay, so let us take an example for PRCP. Okay, so the probability of PRCP is high, then definitely it will be a raining. Okay, and if you take this is a maximum temperature, okay, with respect to T max, if the temperature is maximum, okay, what it will show? So we are having distribution. If the temperature is maximum, we are having some high percentage of getting rain. Okay, and this falls is like low value of percentage whenever we are getting the no rain. Okay, so it will plot a PRCP Tmax, Tmax, this is Tmax, and Tmin is a Tmin. Okay, so we can relate each and everything with respect to this. Okay, and then so this plot. Okay, to find, so what is the major difference, or what are the how these both the trues and false look into the 3D plane. Okay, for that I'm using the KD plot. Okay, so KD is also it can be also used to find the univariant analysis. Okay. Okay. So from this graph, we can see that we can able to classify this thing, but if you can able to do by drawing the straight line, then it is called a linear regression, but it cannot be drawn or it cannot be classified using the straight line. Okay, so we need to find some other techniques to solve this particular problem statement. Okay, so after doing, so the next step is doing the categorical encoding. Okay, so whenever we are dealing with the classification problem, so what we need to do is we need to convert all the categorical variables into numerical variables, because the machines will not understand the numeric categorical variables. Okay, so the machines will understand only the numerical values. Okay, so we need to format that. So rain equal to p dot get dummies. Okay, so get dummies, and that is nothing but, so we are going to get the dummy values for rain. Okay, so whenever we are having a true value, then the value would be like 1. Okay, So we don't have any values for false. Okay, so initially it is called rain. Now it has been changed to true. Okay, so if it is satisfy this condition, it will be true. If it is not satisfy condition, definitely it should be 0, right? So that's why we are having only one column here instead of having the 2 column. Now you can see the rain has been changed. So initially it is, if I print the first 5 rows, so rain 0 0 0 0. Sorry, so it is tail, right? That is, yeah. I can print first 5 rows. I can see rain because it has been rechanged, formatted. Okay, so before that it is called rain true. Okay, after doing all these manipulations I am running, so it will take recently updated df value. Okay, so this is what all about the data preparation. The next step would be like building the model building. Okay, yes, Samir, you can ask your question. Is there any doubts? Okay, so once the model, the data set has been done all the EDA process or on doing all the necessary stuff, the next step is to show your data set to the model. Okay, so I'm going to use from sklearn library dot model selection underscore selection import train underscore test underscore split. Okay, so from sklearn dot metrics import classification report, and then from sklearn import metrics. Okay, so let me run this code. So sklearn is nothing but it's a scikit-learn library, okay, which is used to do a model selection and also do evaluation metrics, and then we can also calculate some of the metrics for the understanding the model performance. Okay, so whenever we are dealing with the machine learning algorithm, okay, so we need to give the input and the output. Okay, the machine will try to understand the mathematical equations between your mathematical relation between your input and the output. Okay, so x equal to df. Okay, so this prcp, tmax and tmin is are the input features, and so y equal to df, rain is our output. Okay, so then you can print your x dot shape and y dot shape. You can see, so the x dot shape is 25,548. Number of column is 3, and we are having the y shape dot 25,548 because only we are having a rain here. Okay, so the next step is to split the data set. Okay, I'm going to split the data set into 2 tests. One is a training data set and another is a testing data set. Okay, so I'm going to use a train underscore test underscore split library. Okay, so the x and y. Okay, so for the test size, I'm going to take a 25% of data sample. Okay, so if I have the 100 data samples, I will take a 25 data samples for model evaluation. Okay, so how I am going to take the data set, I'm going to make use of the random set. That is, so randomly at every 40-second data point will be captured and the test data. Okay, so let me run this code. Now it has been completed. Okay, so the first step is whenever we are building the machine learning model, we need to build the baseline model. Okay, so whenever we are discussing about the baseline model, for classification, the baseline model is called logistic regression, and for regression problem, the basic baseline model is called a linear regression. Okay. So from sklearn.linear model, okay, I'm importing the logistic regression. Okay, so logistic regression is nothing but it is a library that has been used to, or algorithm that has been used to do a binary classification. Okay, guys, so that's why I'm using the logistic regression. Okay, I am just calling the logistic regression algorithm. Okay, so once I have called the logistic regression algorithm, so next is a fit. Okay, so the fit is nothing but it will use to train the model. Okay, so logistic dot fit Otherwise, you can rename this as a model for better understanding. And then we have to rename this called model.fit. Okay, so prediction equal to model.predict xx. Okay, so for training model, we need to give x train and y train. For testing, I'm going to make use of the xx because we are having the xx here. Okay, so x train consists of your input features and y train consists of your corresponding output. Okay, but whenever we are going for testing, we need to only give the input features, not the output. Okay, and I'm going to print the classification report. The classification report is nothing but to get the detailed information about all the distributions of evaluation metrics. Okay, like precision, recall, accuracy. Okay, so let me run this code. Okay, so now the training has been completed. Okay. So for precision, for class 0, the precision would be like 0.90, recall is 100, and F1 score is 0.94. Okay. So in machine learning algorithm, we are having a different set of classification metrics such as accuracy, precision, recall, F1 score, Matthew correlation coefficients, kappa score. Okay. But this scikit-learn library will have the in-depth classification metrics of precision, recall, and F1 score. Okay. So it will have the class-wise distribution. But if you want to calculate, just you can add these two value divided by 2. Then we can have the average precision of the model. Okay. So this is a logistic regression. The next algorithm what we are going to use is called a decision tree algorithm. Okay. So the decision tree algorithm is nothing but it is a tree-based algorithm. So where it will be majorly uses the if-then rules to derive the output. Okay. So from sklearn.tree input decision tree classifier. Okay. And then again here also I'm going to make use of model.fit, model.predict. Okay, so let me do. So all the steps are common. Only thing is the importing the necessary libraries. Okay, so these 2 steps are important, but all other 3 steps are very easy, and is a quite replicate of both the things. You can see. So in the logistic regression, the average precision would be like 0.94. But if you take this, the average precision, it is 100. All the values are 100% accurate. Okay. So let me check for the random forest. Okay. So random forest is nothing but it is a bagging technique. So where we are having a different set of trees. Okay. So the decision tree we are having only one tree. But if you take a random forest, here we are having the multiple trees. Okay. So let me run this code. So you can also see. So we are having a 100% accuracy or 100% value for all the things. Okay. So the thing why the tree-based algorithm is giving better thing is, so whenever we are having the if then else conditions, like so if these conditions are satisfied, it will go on get a rain. Okay. If this condition is not satisfied, then it will not definitely rain. Okay. So this if then rules or works quite well with all the tree-based algorithm like random forest, decision tree, XGBoost. Okay. And then I'm going to use the SVM. Okay. So I hope everyone know about the SVM, right? So SVM is nothing but it is a support vector machine. Okay. So this support vector machine, what it will do is it will try to map all the feature samples into the I dimensional. Okay. So because whenever we are having the linear data, we can able to solve using the straight line. Okay. So whenever we are having the non-linear data, okay, so we need to have something non-linear to address that issue. Okay. So how can we do that? We can make use of this kernel trick or support vector mission to map all the feature samples in the higher dimension, and we can draw the hyperplane between these 2 data points to get output. Okay. From sklearn input CSV. Okay. So I can rename this a model. Okay. So if I run this, okay, so you can see there we are having the kernel here. Okay. So here the kernel is mentioned as a linear, but in general we are having the different kernels like polynomial kernel, RBF kernel, Gaussian kernel. Okay, so the SVM will have a different techniques for kernel. Okay, so we need to use the more precise kernel for your particular application. Okay, so let me run this code. Okay, so you can see we are getting around 95% precision, 93% recall, and 93% F1 score. Okay, so whenever we are having that if else condition, definitely the tree based algorithm will be a better choice. Okay. So next is going to make use of some ensemble techniques. Okay, so the ensemble techniques nothing but whenever we are having the multiple models. Okay, like I am going to build some 4 such models. Okay, I can give the data set to all the models and I will take the average of the output. Okay, so some of the ensemble models are quietly categorized into boosting, bagging and boosting. Okay, so the random forest algorithm is one of the best example for bagging algorithm. Okay, so already we have seen the bagging, then we will discuss about the XGBoost here, the boosting algorithm. Okay, so import XGBoost, so xg equal to xgboost dot xgboost classifier. Okay, we can make use of the decision tree as a classifier and also for regressor random forest also make useful for both the regression and classification problem. Okay, and also XGBoost. So xgb.fit, I can rename this as a model to a better understanding. Okay, so let me run this particular cell. You can see, so this XGBoost algorithm is also a tree based algorithm. Okay, so that's why it is giving a 100% accurate. Okay, so any doubt with respect to this machine learning algorithm? Okay, so I will give 3 minutes of time. Okay, if you have any queries you can ask, then I can go and discuss for ANN algorithm, and yeah, that's it, ANN algorithm for this particular problem statement. Okay, so any doubts with respect to the machine learning algorithms? So it will be good if any 1 or 2 questions from the audience side. So before getting into the ANN. No questions from audience side. You can post your question in the chat box also. Okay, I can read and discuss about that. Okay, so there is no question, it seems. I can go and discuss about the next. So there is a question from Prakash. There is no any other algorithm to find any better solution. How can we define that as a better solution? Prakash, can you unmute yourself and you can ask your exact question? Otherwise, you can just reframe that question. I can't be able to understand that. Prakash, you can unmute yourself. You can unmute and Ask your question. Okay. So, as the question is, what I understand is that we have discussed multiple algorithms. Okay. So, is there any other algorithm other than this? Okay. Yeah, definitely we are having other than this. Like, if you take classification, we are having a neighbor-based algorithm, k nearest neighbor, and then we are having ADA boost, CAD boost, light gradient boosting, and gradient boosting. Okay, so we are having some quite a good number of machine learning algorithms. Like you can name around 13 to 14 machine learning algorithms. Okay. So let me get into the final part for this particular problem statement. Okay. So we know that the machine learning algorithm. Okay. The next algorithm is called the artificial neural network. Okay. So this artificial understanding of this artificial neural network is very much important for those who are want to get into the field of deep learning. Okay. So can anyone say what do you mean by artificial neural network? What do you mean by ANN? Or what are some of the applications with respect to ANN? So we are having good number of audience, but I am not getting any answers. If it's like a one-way communication, it will be very bored, guys. Try to answer something. It may be right or wrong. You can just answer what you understand from the name called artificial neural network. Okay, so I'm not getting any answer. I can get into the session. Okay, so the artificial neural network is nothing but it is like how the human brain is training. Okay, or how our human brain network is working. Okay, so we are going to mimic that thing to process the information. Okay. Okay, so we are having some input layer. Okay, some hidden layer and output layer. Like, okay, so just give me 1 second, guys. I will drink some water. Okay, sorry guys, I have some throat infection. That's why. Okay, it is like this is what a neural network. Okay, so where we are having a input layer and some multiple hidden layers and the output layer. Okay, So these are the inputs what we are giving, that is a CSV file, okay, and this will process inside this particular hidden layers and we will get the output. Okay, so in order to deal with the ANN network, okay, we need to use the Keras library. So import Keras. So from Keras.layers import dense, from Keras.models import sequential, and from Keras.layers import dropout. The data set shape will not be different. Okay, so we are going to make use of the same data set, and then model equal to sequential. So this is the dense layers. Okay, so I'm going to build a dense layer, 3 dense layers like this, and this is a, so this dense layer with having a 5 number of neurons, that is a 5 units. Okay, so if you see this here, the dense layer is 32. Okay, so like this I'm going to have a 32 such neurons in this particular layer. Okay, so dense equal to 32, and the activation function what I'm going to use is I'm going to use the ReLU activation function. Okay, so and then the input dimension is 3 because the number of columns is 3. Okay, and I'm going to use a dropout. Okay, so in this, so whenever we are dealing with machine learning and deep learning algorithms, we are having the problem of overfitting and underfitting. Okay, so in order to remove the problem of overfitting, we need to use this dropout technique. Okay, so the dropout is a regularization technique that is used to regularize your built model. Okay, and then I'm going to have another dense layer with the 36 neurons with the same activation function, and the output I'm going to have a dense with 1 unit because we are going to have either true or false. Okay, then the activation function what I'm using is a sigmoid activation function. Okay, so this is what a model building. So next is a model compiling. Okay, so to compile the model we need to process, we need to give some of the parameters. Okay, so I'm going to use the optimizer equal to Adam, and loss what I'm going to use is the mean square error, and the metric is accuracy. In sometimes we will use a loss is the binary cross entropy or hinge loss like that. Okay, but for this particular application I'm going to use a mean square error. So let me run this code. So this is the model summary. I'm going to have a 128 parameters in dense layer 1 and 538 parameters dense layer 2 and 17 parameters. Okay, so the total number of trainable parameters is 673. That is, that number of weights and bias are consistent inside that particular model. Okay, so the next and final step is model training. Okay, so to train the model, I'm going to use the command called model.fit. I have to pass our X train, that is your feature, and your Y train, your label, and batch size, and epochs equal to 10. Okay, so batch is nothing but the entire data set is being divided into 10 batches. Okay, let us take an example. I am having around 25,548 data points. Okay, if I divide it by the 10, okay, so in each and every batches I'm going to have around 2,500 data points. Okay, so this batch size will use to speed up the training process. Okay, and the epoch is 10. That is how many times you are going to show your entire data sets to the model. Okay, let us take an example. I am having the 10 images or 10 data points. Okay, if I show all these 10 data points to the model at one time, then the epochs would be like, if I show the same 10 data points again to the model, then the epochs will be 2. Okay, if the epoch is equal to 5, then it means that I am going to show the entire data sets 5 times to my model. Okay, so that is what we call the epochs. Okay, so let me run this code. You will get the output like here. So for epoch 1, the loss is 0.24 and accuracy is 66. Okay, you can see after the epoch 10, so we are getting the accuracy of 90%, but previously we are getting around 98 and also 100%. Okay, so let me check whether if I increase the epoch, will my accuracy will change? Okay, let me check that. I'm increasing the epoch equal to 25 now. Okay, you can see this. At epoch 23, I'm having the accuracy of 92.8%. But you can check at the point of 25, it is 67%. So definitely, so the increase in the epoch will definitely increase the accuracy, but at certain time, it will start getting reduced. Okay, so we need to have the optimal number of epochs to get the desired result. Okay, so for doing so, we are having some set of libraries. We can make use of the yearly callbacks or yearly checkpoints like that. If the keras, okay. Let me print. We are having the loss and accuracy. I can just go and plot that. And see, the accuracy is constantly increasing and increasing with up to the point 23rd. So after it seems it is reducing. Okay, so and this is the optimal point where we need to stop our training. And then I can print the classification report. You can see so model is poor in doing so. Okay. So I can change the epochs to 10 now. Okay, now you can see now the accuracy is 92%. You can clearly see the difference. Okay, so it is, you can see it will gradually increase. Okay, so at some point it will start increasing and it will be steep. So you can see the model is not that much good with respect to a classification report, because for class 0 the precision is 1, for class 1 the precision is 0.43. Okay, so this is all about this particular thing. Okay, so like weather prediction. Okay, whether it will be a rain or not. Okay, so we can have a 5 minutes of discussion over this particular problem statement. Okay, then we can go and get into the next part. Okay, so before you ask a question, I will just ask my question, only one question. Okay, so can anyone infer what is instead you are getting derived from the machine learning algorithm and deep learning algorithm for this particular data set? Okay, what is the inference? Can anyone say? Please I request someone to answer. Okay, what is the difference between the machine learning and deep learning after this application? Or what you can understand from this? So why the machine learning algorithm is providing better results when compared to the deep learning algorithm? So 1 or 2 points is more than enough for me. Either you can unmute yourself or other you can just post in the chat box. Yes, Soumya, you raised the question. And is there any question from your side? Okay, so I'm not getting any answers or any question from participants. Okay, so I can understand that you know everything about whatever we have discussed. Okay, so by keeping it that mind, I can get into the next part. So how many of them know about NVIDIA? Okay, so let me give a quick idea about NVIDIA. Okay, so the NVIDIA is organization. So we are manufacturing a graphical processing unit, say especially for gaming laptops or dedicated deep learning applications. Okay, so most of the organizations I hope from Tamil Nadu and also from Andhra Pradesh, they are moving towards to build their own workstations. Okay, so like DGX server. Okay, so on most of the organizations also started that AI and data science um, UG degree. Okay, so if you want your students to get into the field of data science and machine learning, then having the hands-on on any of these NVIDIA GPUs is very must, because most of the organizations are make use of the NVIDIA GPUs. Okay, so you can also try to learn about the CUDA programming. Okay, to code the GPUs to get the better results out of that. So we are the major pioneer in manufacturing the GPUs. Okay? And then we are also doing some corporate social responsibility by providing some uh, useful learning materials or teaching kits to the faculty members in the organizations, engineering organizations. Okay, so if you want to make the benefit out of that, go and request a teaching kit to the NVIDIA teaching it portal. Okay. So and then also we are also providing this free courses with respect to the different technologies like deep learning for medical imaging, deep learning for natural language processing, and advanced deep learning algorithms. Okay, so this is a quick info about what as a deep learning institute we are doing to the institutes across the world. Okay, so if you are also planning to do some or planning to organize such thing in your organization, so please do let me know. Okay, so we can collaborate and so we can plan for a session over these advanced topics. Okay. So for this particular session, we already discussed about how to predict the weather. Okay, so and then the next what I'm going to discuss is called disaster risk monitoring. Okay, so this is a quite big course. Okay, so I am planning to complete a part of this for morning session. Okay, so it will take another half an hour of time. Okay, I don't want to take so much of time in discussing that, and then we will meet again in the afternoon. Okay, so to complete this particular coding. Okay, so how many of them are aware about TensorFlow and Keras framework? TensorFlow and Keras. Okay, so this is the NVIDIA Deep Learning Institute library. I'm going to make use of Deep Learning Institute and also Microsoft Azure platform to run the particular cell. Okay, so here what we are going to do is we are going to do some program applications on disaster risk monitoring. Okay, so it will take some time to connect with the NVIDIA server. Okay, so it will get another 2 to 3 minutes to get connected. Okay, so please be patient before we can start this lab. Okay, so meanwhile, during the running, I can give some idea about deep learning algorithms. Okay, so
அந்த இடத்துல அங்கேயே
okay, so if you take a deep learning algorithm, I hope my Jamboard is visible to everyone, right? Surround service visible, right? Whiteboard?
Yes, sir.
Yeah. So if you take a deep
Yeah,
learning
it's visible, sir.
Thank you, sir. Okay, so we mostly deal with CNN algorithm, RNN, and GAN. Okay, so whenever we are having the image-based applications like image classification, regression, object detection, then we can go with the CNN. So whenever we are having with respect to any sequential data, okay, like image captioning, that and all, we can go with the RNN. Okay, RNN is nothing but it's called a recurrent neural network. Okay, so if anyone watched the recent Google I/O 2020, okay, so let me play that video also.
I'm Abhirami. So I'm based out of Chennai and I did my schooling, college, everything from Chennai. Previously I was working.
Let's take language as an example. Language.
My mother speaks Mandarin, and I speak English, which is a strange.
So please watch this video. Okay, this is one of the best application of how the AI or how these deep learning algorithms will be used for Google Glass prototype.
thing. 他讲英文，我可以听得懂，可是我讲不来嘛。
We'd love to be able to share with you the new prototype we've been working on. You should be seeing what I'm saying, just transcribed for you in real time, kind of like subtitles for the world.
What we're working on is technology that enables us to break down language barriers, taking years of research in Google Translate and bringing that to classes.
You see me? Oh, see through. I'm actually looking straight into your eyes, and it seems like you're looking right at me.
Making access to information just instant and intuitive. By doing that, technology fades into the background, and we're more connected with the people and the things around us. Giving people the gift of communicating with anyone, no matter what language.
沟通，我爱你。
Okay, so these are the one of the application of that recurrent neural network. Okay, so most of you are aware about Google Translator. Okay, so what they have done is they have get into the some next advanced level by integrating the glasses with the Google Translator. Okay, so whatever we have speak, it will try to communicate the information to their own language. Okay, so this is one of the application of this recurrent neural network. Okay, so now it has been opened. So we are going to discuss about disaster risk monitoring using the satellite images. Okay, so for this particular notebook, we are going to discuss about some of the topics like what are the disaster risks. Okay, like flood detection. How can we detect the flood from the satellite imagery and making use of the computer vision techniques and some deep learning based monitoring system. And then we are going to have what are the challenges we are having with respect to predict the floats using the deep learning algorithms, and what are the different data sets we are having, and how can we do some EDA analysis to have the clear idea about what exactly data is stealing. Okay, and then data pre-processing with DALI. Okay, it's nothing but a library which is used to do all the data science data pipelining. Okay, so the disaster risk monitoring. Okay, so you can see the natural disasters such as flood, wildfire, drought, severe storms. Okay, so we are having throughout the world. Okay, and it is causing the billions of dollars in damages and uprooting communities, ecosystem, and economies. Okay, if any one of the countries are affected with any one of this disaster, then the economic will go down, and we have to start from the scratch. Okay, the ability to detect, quantify, and potentially forecast the natural disaster can help us to minimize their adverse impact. Okay, so either we can reduce the number of lives that has been human lives if you have the good prediction capability. Okay, and then also we can able to reduce some of the economic losses also. Okay, so while this lab focuses primarily on detecting the flood events, and it should be noted that the similar applications can be created for other natural disasters. Okay, so what do you mean by flood detection? A flood is an overflow of water that submerges the land that is usually dry. Okay, so they can occur in different conditions, like overflow of water from water bodies, like from dams or any lakes like that, an accumulation of rainwater on the natural unsaturated ground in the aerial flood. Okay, and then when a flow rate exceeds the capacity of river channel. Okay, so these are some of the scenarios where we can get this flood. Okay, so this unfortunately the flooding events are the rise due to the climatic change and sea level rise. Okay, so this is where the clear climatic change will occur. Okay, so we are saying that okay, due to heavy rain we are getting the flood, but not like that. Okay, so every year the level of the sea is rising due to the climatic change. Okay, so the entire Antarctic ocean, the ice has been melting down due to the rise of temperature. Okay, so this is due to the increase in the frequency and the intensity, the topic of the flood has been gone international attention in the past few years. Okay, so most of the industries are closely working towards how to make use of how to reduce this climatic effects on the Arctic or Atlantic oceans. Okay, we need to reduce that melting down of ice. So whenever the melting down of ice increases, the sea level also increases. If the sea level increases, then the getting flood is very it is like such a very basic thing. Okay, so that's why they have developed some sustainable development goals towards this particular flood. Okay, so what are the different data variety of source resources we are having? So we are having live earth observation data via satellites and surface reflectance, and we are having some soil moisture, snow cover, and snow water equivalent, and then topography and meteorology. Okay, so these are the some of the areas where we can get the data sets from the various resources. Okay. So I know most of you know about what are the satellite images. Okay, so satellite image nothing but the images that are captured using satellites in the orbitals. Okay, so we are having a geostationary, low Earth orbital, LEO, MEO, and GEO orbits. Okay, so we can, with respect to the different kilometers, the name of the satellite will be different. Okay, if it is less than 1,000 kilometers, we can name that as a low Earth orbital. If it is around 1,000 kilometers to 37,786 kilometers, then we can call that as a medium Earth orbit. Okay, if it is more than 35,786, then we can call as a geosynchronous Earth orbit. Okay, that is a geostationary orbit. So for capturing the float monitoring, we are having two satellites such as Corpinus Central 1 and provides the C-band synthetic aperture radar image. Okay, that is SAR data. Okay, so satellite uses that SAR data and opposite of the optical satellites that uses are visible or near infrared bands. Okay, so I'm not want to get into the detailed depth about what is the SAR imaging. Okay, but what the Central will do is, so it can monitor the sea ice and icebergs, and monitoring of land that is icelands, and river and lake monitoring, oil spill and ships, marine winds and waves, land use changes, agriculture deforestation, land deformation, and support to emergency management such as floods and earthquakes. So these particular satellites will work for all these applications. Okay, so next is the computer vision. Okay, the out of that of this type of disaster risk monitoring system is one or more machine learning models to generate the insights from the input data. Okay, so these are generally a deep learning neural networks models such as trained with a large number of data set or image data set. Okay, so some of the applications what we are having is called the classification, object detection, segmentation, like that. So if you take classification, it is used to identify whether the object contains an image or not. Okay, like it is a task of labeling the given frame with one of the classes that the model have been trained. So this is an example of classification. Okay, we can say whether the particular image of the dog or not. Okay, if you are saying that, then it's called a classification. Just give me a second. Okay, so if you take object detection, so if you want to detect, okay, what is the exact location the object is present, so we need to go for an object detection. And segmentation nothing but if you have the multiple objects in an image, we can go and do the segment object wise, and we can get the clear idea about that. Okay, so it can be used for your autonomous vehicle, medical image segmentations to identify the tumor size, like that. Okay, so for doing the deep learning based disaster monitoring system, first we need to have the satellite remote sensing data, and the data is used, that is a continuous data to train the deep learning neural network model. And we need to have the different models and versions are managed by the model repository, and model inference performance is actively monitored, and data is passed to the inference server to generate the insight, and these deep learning based insights can be used for further analysis and or raise alerts. Okay, so it is a data science pipeline. It's nothing but we need to have the data, and after the data we need to train the model continuously with the incoming data, and we need to have a different set of model versions. Okay, and also we need to model manage properly in the model repository, and we need to have the model inference performance. We need to actively monitor that, and we have to pass the data to the inference server to get the real insight. So this full entire pipeline. So it's a training the model, and this is a training the data set, and we have the training the model with the new capability, and this is the inference we are getting. Okay, and what are the challenges we are having with respect to deep learning? Okay, so training the accurate deep learning algorithm from the scratch requires a large amount of data, and then acquiring them is a costly process since they need to be annotated often manually. And then development often requires knowledge of one or more deep learning frameworks such as TensorFlow, PyTorch, or Caffe. So deep learning models require significant effort to fine tune before it's optimized for inferences. Such as for inferences and production ready. Okay. Deep learning models require processing the data in real time is computationally intensive and needs to be facilitated by software and hardware that enables low latency and high throughput. Okay. So some of the NVIDIA toolkit where we are going to work is NVIDIA DALI and Tavo toolkit, TensorRT, and Triton inference server. Okay. So first is a Sentinel-1 database, data public access. Okay, the Sentinel-1 SAT data will use available from ESA via Corpinus Open Access Hub. So they maintain an archive is committed to delivering the data within the 24 hours of acquisition and maintains the recent month of records. Okay, so they are also available in via NASA Earth Data Search or Vertex or Alaska Satellite Facility Data Portal. So if you want to any satellite images, you can go and check with this particular databases. So this is a SAR image, SAR data. Okay, so we need to do exploratory data analysis to get a clear idea about what is exactly present in that particular data set. Okay, so this is the input image. You can see we are having the green regions and blue regions. These blue regions are the flooded region. Okay, and so this is the input image, and we need to create the mask for that particular image. Okay, so today morning session we'll discuss about how to create this particular mask. Okay, and I will stop here, and then we can go. We can discuss in the second half. Okay. First, I need to unzip the folder. Okay, so once we have unzipped the folders, okay, so we are having a different regions from India, Sri Lanka, Paraguay, Somalia, Pakistan, like that. For all the areas, we are having a JSON files. Okay, so I can go and check libraries, so environmental local data directory. So data, I can see images, all the images here. You can see this is the image, and if you take corresponding mask, this is the mask image. So you can see the floated area. Okay, so this is what a data sets, how it's look like. Okay. I can print some of the images and to get a clear idea about that. Okay, so for Bolivia, I am having 15 images. For Nigeria, I am having 18 images. For Somalia, 26. Pakistan, 28. Mekong, 30. Spain, 30. Sri Lanka 42, Ghana 53, Paraguay 67, India 68, and USA 69. And I am also having the corresponding mask also. So this is the distribution of the data with respect to the latitude and longitude. So we are having this is the data distribution, and you can clearly see that. So the distribution data is very vast. So we are not getting particular more data sets in the particular latitude and longitude and latitude. Okay, so we can go for a geometry. So I'm going to print images with respect to Spain and also their corresponding mask. Okay, you can see. So this is the Spain image. So these are the areas which is covered with the flood. Okay, so that's why we are getting the white region here. Okay, so I can go with by the boundaries. Okay. So these are the data. These are the corresponding image, and this is the corresponding mask. Okay. So any doubts with respect to these guys? Okay. So up to data exploration I have discussed here, and then for EDA process and model building I will discuss in the afternoon session. So if you have any doubts, you can raise your question here. So any doubts?
Excuse me, sir.
Yeah, sir.
It's like an disaster oriented pictures you are shown based on various countries and like. So, like in the above, based on the rainy, during the rainy situations, there are various diseases are coming to rise now. So, is it possible to predict what type of diseases mostly is coming to rise for the human peoples during the rainy season and winter season, like?
For this particular data set, it is dealing with the flood. Okay, so the rainy season will not be like considered as a disaster. Okay, if it is rain more than 10 days, so then we can define that as a disaster. Okay, so if there is more than 10 days of raining or 5 days of continuous raining, so then we may result in the flood, right? So the flood is nothing but it is the excess of water level. Okay, so it has been captured by the satellite images.
Okay.
So it is showing that, okay, so if I am getting the flood in particular region, okay, if I predict that earlier means I can prevent some other regions which are going to get flooded. Okay, so like the early warning system.
Okay. So, disease relevant prediction we may able to. So like, stir is okay, fine. Diseases according to disease.
So you are asking that how that climatic change will affect our human body, right? And what are the different
Yes.
scenarios? Yeah.
Yes,
So the climatic change, if you
some
take the
new viruses. So yeah. Because by asking just now 1 month before also some new type of viruses are coming to affect for an child children. They are having 2 years old or 3 years old. They are having some symptoms. They are feel like and they not like to eat well, and there are some injuries are coming in their mouth like that. We are asking the doctor, they said like is a new virus like. So according to the climate change, some new type of viruses are coming each and every situations.
Yeah, so the new virus nothing but it is a mutant of the previous one. Okay, so the virus will be mutant each and every cycle. If you take the COVID, so we are having different mutants now. Okay, so if the body is adapted, the thing is that whenever there is a difference in your temperature of the body, so we may get a different. We are also having everyone having the virus, but due to that difference between the viruses, we will get that difference between the temperature the viruses will be get activated. Okay, some the virus will be activated during the cold time, and some virus will be activated during the hot time. It's all depends upon the human body. So whenever we are getting the new variant, it will not directly related to the climatic change. So the virus is already present in our body, but due to the outside exposure, like the temperature or it may be a cold, the virus getting activated. Okay, so that is why we are getting some frequent fevers during the cold seasons.
Okay, sir.
Okay, so if you want to deal with respect to this, how the
Okay.
virus are reacting, so we are having another area in the deep learning techniques called gene classification or protein prediction. Okay, we can make use of this type of applications to identify the virus inside or analyze the DNA of the human body.
Okay. Okay, sir. Another one
Any other
question,
questions
sir.
from audience side?
I would like to ask. Yeah, one more question, sir.
Yeah.
Um, Sir, by using a deep learning, we can able to predict only the already existing type of diseases, like, or we may able to predict a new type of type of disease, or is able to come, like, because already there are some viruses are something is available. So in this type of climate change, or in this situation, this type of disease is only coming for the here, is coming to affect the peoples, like, they may be in adults or in children's. This climate duration situations, this type of disease is only coming. So likewise, we may able to predict, or new type of disease also is able to come.
So if we are having
What
some
I'm trying to
sampled
ask
data,
now.
yeah, what I
Yeah.
you are telling me that, so whether we can able to predict the new diseases using these deep learning algorithms. Okay, so we
Yeah.
can't be able to predict the new diseases using these deep learning algorithms. But if you want to find any new drugs, okay, so whenever we are visiting the hospital, also the doctor, so if you go for a fever to visit the doctor, okay, so what the doctor will give is, so they will recommend two tablets, some tonics, and some injections. Okay, so initially first 2 days it will not be cure the disease. Okay, so it will try to normalize your temperature. So likewise, if you are having the data points like this, then we can train the deep learning algorithms to do their new disease prediction. But in general, it is not possible, because even no one know about what type of diseases will be happening in the future. But for the potential drug production or the drug prediction, so we can make use of this deep learning algorithm for the drug prediction applications.
Okay, sir. Sir, another one, you are already asked. It's like, what is the artificial neural network like? So actually, you are conveyed like, it's going to mimic the human brain, how it is the human brain, how it is a work, how it is act. Like in the same, we have to make a neural network. It's going to mimic like a human brain, right? So how much closely it's going to mimic human brain? So if we know well, human brain is what, it's not like anything. So it's very excellent, exact one. So how much deeply or closely that we are constructed artificial neural network is going to act or work like a human brain?
Yeah. So the mimicking is nothing but some of the human doable tasks that can be able to solve using the AI system. But if you closely watch in the recent developments of development China and Japan, okay, so they are making use of these AI robots to deploy them as a news reporter. Okay, so one of the popular news channel in China, so they have make use of these humanoid robots to deliver the news.
Yeah.
Okay, so how the normal people can behave like for different scenario, like, so whenever we are sharing the happy news, the face will be different, right? The feature of the face will have the happiness. So whenever we are delivering the sad news, the feature of the face will be in sad mode. So like that, nowadays the robots are capable of providing the emotions also. Okay, and I'm not saying that all the tasks that can be doable by the machines, but most of the tasks that can be doable by the machines, like 90 to 95% of what are the human tasks we are doing. So nowadays we are having that sorry, emotion intelligence inside the humanoid robots, so to have the to make them also like feel like a human. Okay, so because the ethical AI is another very important area. Okay, because we need to focus on this ethical AI to deliver a number of applications. If you take the medical imaging or doing any robotic surgery, so we need to practice some ethics over there. Okay, so this is where the recent research is going, but in future definitely you can see in, so now they are predicting that in 2050, so there is no mobile phones. Okay, so all the human body or all the human's brain have been imprinted or implanted with the chips in the human brain. Okay, so there is no mobile phones that are going to available in 2050. Okay, so if
No.
there is a this single chip that can be implanted in the human brain, it can do all the process. Okay, whatever the mobile phones are
Okay.
doing, it can do all the process.
Okay. Okay. So.
Yes, that is the power of AI system.
Okay, sir. Sir, actually, in machine learning, it should be need of just it's like a conventional computers are available means it is more enough. But why the deep learning algorithm is expecting a more powerful hardware than machine learning? I thought machine learning compared with the machine learning, the deep learning it's provide more accurate result. And so it is the actual reason that the deep learning is expecting more powerful hardware. Are there any other reasons? Compared with the compared with the deep learning, machine learning is an very cool and nice. We can able to get some work easy. It's like, but some conventional computers or hardwares are enough for machine learning. But deep learning is expecting more powerful hardware than deep learning algorithms. So, what is the reason?
Yeah, so it's a very good question. The what you are asking that. So even though if we are having a very small systems or normal computers, we can do the machine learning and also getting the desired result. Okay, why it is a need of some advanced hardware accelerators for the deep learning? Okay, so the thing is that whenever we are having very linear data, okay, like the text or tabular column format of data, we can make use of the machine learning algorithm. It is very clear. But whenever we are going for any some advanced or high dimensional data like image, video, and then satellite images, because if you take the satellite images, it is a 4 coordinate image. Okay, so in the general it is a 2D. If you take the satellite image, it's a 4D images. Okay, so we are having a different what would I say? So different regions of that. Okay. So if you want to handle this type of algorithms or this type of imaging applications, definitely we need to get into deep learning. Because in machine learning, so there is no need of. So in machine learning, we need to do the feature extraction. But as a human being, we can able to see only the 2D images. Okay, we can't able to visualize the 3D component or 4D component. If you want to do so, we need to have some advanced machine deep learning algorithms, so which is useful algorithms to extract the features on their own. And also, if you want to deal with this type of data sets, so the computation will be very high. Okay, so otherwise, if you train your ordinary deep learning system with ordinary CPU, so definitely you won't get that much of what it is the performance of the model. So the GPU, whenever we want to deal with the deep learning, definitely we need to have some advanced GPUs or advanced computers with i7 processor, because so it will take so much of your memory space. Okay, so let us take an example of 4D image. If you have the 2D image, it is 100 KB. So if you have 4D images, it will take 1000 KB. Okay, so definitely the memory consumption is very high whenever we are dealing with the deep learning algorithms. So that's why in general they are suggesting that so go with the GPU architectures. Okay, so that is a major difference between the machine learning and deep learning.
Thank you, sir. Thank you very much, sir.
So any other questions from audience?
Respected faculties and the students, if you have any questions, please feel free to ask the Chandran sir. Unless otherwise, we have to wind up the session right now. So please, you have any questions relevant to this particular concept, feel free to ask. So make the session as a wonderful one. Hello, Chandran sir.
Yes, sir.
So I think your session is very clear within the faculty. It's reached nice. I think they have don't know any queries for you now. So we have to wind up the session now.
Yes, sir. We can wind up.
Okay, thank you, sir. Thank you, faculties. Thank you for your attending this session. So please feel free to ask your questions with the respected guest to make the session as a wonderful one and an interactive one. So your next session is going to start at 2:30. So please have to join the session at 2:30 sharply. So for your next session is going to handle by the Prabhakaran sir, and upcoming Chandran sir will coming to join with you. So have your wonderful lunch, and please come back the next session at 2:30 p.m. So thank you, faculties and students. Thank you, Chandran sir, for present and a wonderful session. Make this session as a wonderful one. Thanks for your content.
Thank you so much, sir.
Thank you, sir.